Okay, so let's get started. Welcome to this, the third of 4 weeks of Tesena Fest. Each week we have dedicated to a different area of software testing. In the first week, 2 weeks ago, we had testing in automotive. Last week, we had testing in Agile and DevOps. Next week, we have testing with AI and machine learning. And this week, we're going to focus on continuous testing. Today, we have 4 great speakers lined up. My name is Phil. I'm going to be the moderator and the guy who's going to try and just mute somebody, try and make some jokes as we go along. Okay, so before I start, just some housekeeping I'd like to go through. The first point is we're using Slido. You can see on the screen, hopefully, a poll running, asking where you're from. As you can see, we have a nice international audience, so we're really, really happy about that. As we start the presentations, I'll switch to Q&A mode. So into Slido, you can put any questions you want to ask the speaker. You can put them there at any time you want, and we'll get to the questions at the end of the talk. Not only is the chance to ask questions via Slido, but when the presenter finishes his presentation, he's going to move over into our virtual coffee corner. You'll see a link for the coffee corner on the live stream underneath the video, or if you're on Teams with us, then we'll post a link within the chat during the talk. So if you've got any questions you want to discuss, because it's a two-way conversation in the coffee corner with the presenter, then the place to go is the coffee corner. Also, we'd like to ask for your feedback. We'd like to keep getting better and better at what we do in Tesena Fest. So we very, very much appreciate if you could take a minute or two to provide some feedback. Again, there's a link for the feedback form underneath the live stream. And we'd like to mention we have a competition. Tesena provides a lot of software testing. You have a chance to win the software training course of your dreams, completely free. And all we're asking you to do is to make a post on some social media, Facebook, LinkedIn, or whatever. When you make a post about you're attending Tesena Fest or something about Tesena Fest, make it look as festival-like as possible, and send us a link or a screenshot of that post to our email address, events@tesena.com. And when the conference closes at the end of next week, we'll select the winner. And finally, I'd like to just thank our conference sponsors. These are the people who are providing, these are the companies and organizations who are providing the people, the know-how, the time, the ideas that we're sharing during our Tesena Fest. So thanks very much to those. So now I'm going to hand you over to Vishnu, who's a senior principal engineer at DellEMC, and his presentation is called Distributed Workload Generation for Performance Load Testing Using Emerging Technologies. So Vishnu, over to you.
Hey, thanks for the intro, and thanks for giving the opportunity for me to present the JAAS in this particular conference. And I'll share my screen.
Okay, we can see it.
Okay, thank you. So yeah, today's topic is basically we're going to talk about the distributed workload generator for performance and load testing using emergent technologies or open source technologies, we call it out. Okay. So yeah, as Phil has introduced me, and I was working for Dell for last 15 years, working as an automation leader in the validation organization, and I'll be more concentrating on content automation development and developing the tools for process improvement and also tools for the engineering purpose. So I have also submitted I have 9 granted patents in USPTO, and good amount of patents was recognized in Dell Patent Committee also. I was presenting a lot of conferences, presenting my white papers on the presentations and papers on the conferences. Example, PyCon, Step-In, and Targeting Quality, some of these conferences where I presented the different topics in the conferences. So the agenda of this entire presentation covers on the what we as a validation organization, what we do, okay, as a quality team, as a validation organization, what we do, and what type of challenges we have, and how do we overcome within a solution what we have designed, and what is the technology stack what we use, and some of the little more technical aspects of the technology stack, and then we also have a light demo. Okay, so yeah, this is nothing. This is not a sales pitch for any tool or anything. It's basically day to day what are the challenges we face and how do we build a solution using completely open source tools, such a way that any team or any organization can get benefited from these tools and the learnings what we got it over the last couple of years actually. Okay, that's one of the major presentation objective. Okay. So what exactly we do, we actually, from the server validation group, we validate the servers, and we have 3 different locations geo-located across Austin in US, and Bangalore in India, and Taipei in Taiwan. These 3 teams consolidate do the certification of a server end-to-end before it released to the market actually. Okay, it is basically enterprise class servers where we validate this entire end-to-end functionality and sustainability of systems before we release to the market. So I think if you look at any traditional validation models, you will be running an agile model, you may be running a waterfall model for different validation aspects. So we can see the same thing here also, where we will be running a sprints for software components, and we have a product test for the hardware components, and then we will be having a system testing. This is what the phases we call it out. So initially we will be concentrating more on functional testing, component testing, and integration testing. But once we reach to the this particular phase, it's more on a non-functional testing or real customer use cases to try it on the systems and make sure that how the system is behaving or reacting on top of the specific workloads. Okay, so this entire presentation, what we're talking about, this particular phase, what tools we use, and what are the challenges with the current tools, and what we have built for the overcome this current challenges. Okay. So what exactly the system test or enterprise system test we do is that we focus more on a customer validation scenarios. You can look at it, if any customer buy a server, he will be using that server for a database workload or for a mail workload or for a exchange, all these different customer use cases. They'll buy the server and they put it in a production and they use the server actually. So what we do in a system testing or a non-functional testing phase is that we try to simulate the real customer workloads on of a typical applications, what customer uses on the server, and see that how the server is behaving. Is the server is actually getting any issues, or is the server behaving properly? All this testing we do it actually. Okay, so there is a different what do you call it in a process we do with how the customer actually bring a server into data center. We try to configure, then he deploys the application what he wanted to use it for his customer use case, and then we will be try to actually generate load on particular application and keep monitoring that particular application how he's behaving. And then we also do some of the service updates or software updates in the meanwhile. And this is basically a life cycle of entire what you call it in a customer use case, where from the starting point of deploying to the retiring the system from in his data center, in the customer data center. So the main focus of this entire presentation is that how we are able to simulate the customer workloads in our lab, what customer actually able to stress, same thing we are trying to see in our lab actually. So these are basically we are trying to talk about more in this presentation. We told that we are trying to simulate the customer workloads, and for this particular simulation, there are a lot of load generator tools available in the market. The major challenge with these particular tools, we also use some of these tools called Ixia, Load Runner. There are multiple number of tools are there in the market. We also use these tools as part of our initial test phases. But what we observe is that these tools have become more and more expensive, and there are very much licensing every year we need to renew all the things, and they have their own proprietary hardware which we need to use it for using the solution also. For example, if you may have a high-end server, still you cannot use so easily their software stack because you need to buy their own hardware to use their software stack. So it's become more and more challenging because we are actually working more and more servers to release in the market, and time to market and time to release new next generation servers. This has become more and more bottleneck for us to see that using the product what do you call it, current load generator tools which are in the market actually. And also we need to have highly specialized performance engineers to develop the scripts, and also some of the data analytics and correlation. These tools exactly won't meet our requirements, so we wanted to have something where we can get the data more quicker and more faster from this solution. These are the current challenges what we are seeing from the current load generation tools which are available inside the market actually. So what exactly we work there? So what we told is that initially we draw a line saying that how do we look into this entire problem statement and what should work. So initially we called out saying that let's use all open source tools for building this particular solution. Okay, so that was one of the biggest statement we called out saying that we will use whatever the industry-wide lead open source solutions, we wanted to use it to build this particular solution, this particular tool or a solution. Okay, so as part of that, we have explored a lot of multiple load generation performance tools, and finally we decided to use JMeter as one of the industry-wide open source tool for the performance testing solution actually. Okay, and then we also looked at the Dockers for the workload generators, Dockers for the virtualizing the users and all the stuff, then Elastic Stack for storing all the logs and all the details. We have a couple of slides next which can talk about more details on the same aspects. And one thing is that we wanted to use our servers as a load generators. We wanted to make sure that get benefited from our servers, what we ordered and what we can get it, so that we don't need to buy any external servers for the load generators. That's one of the also we wanted to achieve in this solution. And a couple of more objectives of the solution that we should be able to have a dynamic workload generation, so that user can able to change the workload based on the times when you wanted to go high or low or medium anytime. So we should be able to give complete flexibility to that. And also it should be scalable across regions. For example, different teams should not buy licenses and deploy their solutions in their own locations. Instead, that what we plan to do is that we wanted to use across regions using the common network infrastructure. We can able to scale this solution across regions and across labs. So that was one of the biggest requirement for us also in this particular solution design actually. And also we wanted to support new workloads, and we should have advanced dashboards and visualizations for the data correlation and advanced data analytics. So these are the high level solutions. So in the proposed solution we wanted to achieve as part of the object of this entire solution. Okay, so as I mentioned, there are key technologies which we use as part of this building entire solution. Some of the key technologies which we're going to talk about in this particular slide. One of the first one is JMeter. JMeter is basically supports many types of load tests, and it's completely open source, and it's a platform independent. You should be able to run Windows, Linux, any operating system, any VM or any physical system, and it supports very pretty good multi-threading and multi-users execution jobs, and also it's a completely open source software. So we logged first thing is JMeter is our application for the stress and load generation, and then Docker and Docker Swarm. Okay, these are the two solutions where we can able to generate the virtual users in a high scale. For example, you may ask 1,000 users you wanted to hit a web server with a specific web request. So JMeter can able to generate threads, but you need to run multiple instances across the systems to run this particular request. So we use Docker, where we actually keep the JMeter inside a Docker, JMeter Docker container, which is basically able to bring up the containers more faster and able to generate the load. And it's Docker is resource efficient, so that when we wanted to quickly start, it will come up, and once the job is done, it will be disposable more easily. And it's again open source software. Then we use Docker Swarm. There are a lot of questions we got it saying that why we use Docker Swarm, why not Kubernetes and all things. Docker Swarm we use because it's a native Docker clustering solution for orchestration of the Docker cluster, and also it has a REST interface. Again, it's a native Docker application, so we stick to the Docker Swarm, not the Kubernetes. But any organization, any team can use Kubernetes also as part of the solution. Okay. And last one is Elasticsearch. The main thing is that Elasticsearch is our backend database which stores every artifact which is generated over this entire solution, and we can able to use for the live monitoring as well as historical data mining also. And it's a completely open source. It supports a schema-free and REST APIs it has, so that you can able to insert the data and you can able to read the data over the REST interfaces. Okay, so these are the high-level key technologies which we actually, when we design the solution, these are high-level called out what you call technologies. But there are some more open source solutions we used, and that will be bring it up in the particular technology stack actually. So as I mentioned that in the physical layer we have used all the Dell servers. Okay, you can use any servers, but we use Dell servers because of the what available in our labs, and we deployed the Ubuntu operating system on all the nodes what we have, and then we installed the Docker and we created a cluster using all the nodes using the Docker swap. And Harbor is again an open source solution from the VMware, which is basically like a Docker registry where we can keep our Docker images so that we don't need to use Docker Hub. And recently Docker Hub, what we have also has restrictions. So we use completely Harbor so that we can we don't need to expose anything of our Docker images or Docker volumes to the outside world, so that internal Docker registry can able to manage our entire Docker containers. And then majorly the entire solution was designed on the Python and Groovy. Python is basically the programming language where we use all the backend solution development. And Groovy we use for this particular Apache JMeter coding. For example, you may write a web script or a database script or a mail script or a exchange. Any script you want to develop using the Groovy, we can able to develop this particular JMeter scripts. And Groovy is again, it's similar to Java language. So if you are familiar with Java, you can able to write the scripts very seamlessly on this particular script. And Elasticsearch, as I mentioned, it's a backend database for us. It stores all the database, all the artifacts, all the events, all the metrics, what is generated across system, so that we can able to view the data in the live as well as historical data mining. So there are some more solutions are there. Portainer is basically an administrator-based Docker Swarm monitoring software, and Jabex is monitoring the entire cluster, and Kibana and Grafana for visualizing entire workload generation solution artifacts actually. For example, how many workloads are running, what is the workload utilization, and all the stuff. Okay, as well as we have used the Bitbucket for version control, Confluence for documentation, Jira for the enhancement features and requests, all the stuff actually, defects and all the stuff. Okay, this is the high-level stack. Basically, what are the softwares we used, and if you look at it, most of the softwares what we have used is a completely open source solution. So you will be able to find out in the internet, and you can deploy and you can use this softwares in any project for any purpose actually. So now we're going to get into the more detailed solution overview, how exactly the solution works and what exactly it do, and how the way we are able to achieve the load on a systems with a specific workload or application specific things actually. Okay, so as I told you, Axon is basically a lightweight. It's an interface for us users to go and launch the jobs. It's like a web interface for us. So user goes to the Axon, and they says that I want to run a particular workload on a particular server. I want to have 1,000 users to run the load actually. Okay, for example, you want to run a web stress on a particular system with 1,000 users, a specific web application. So the predefined the web scripts are loaded inside the load generator with the containers, and the container will kickstart the particular load generator script using JMeter. And once the JMeter starts, it starts generating the load using multiple containers over the network to your application under test actually, or system under test or application under test. So in this process, what happens is that a server which has an application will be reached out to multiple containers, has a JMeter application using the JMeter scripts is hitting the load actually. For example, you may be accessing a particular web interface for some of the web application operations, or you may be using a database to create, insert, delete data actually. Okay, so indirectly we will be generating huge traffic on your system under test. Eventually, it actually hits your application. So as part of this entire process, we also store all the artifacts from the load generators as well as the system under test to the Elasticsearch, so that what happens is that as a user who is running this particular workload, he can able to go to the Grafana and he can monitor that what is happening on the load generator side and what is happening on the server side. He can able to view in a single console. So this will be useful for the live monitoring as well as historical data analysis. For example, you can come back after 1 year and say that I want to look back a particular workload, what was happened on the particular system and how much utilization happened, how many errors we have seen, as a compared to historical analysis or a historical deep dive also, we can able to look at it, because all the data what we have generated is stored into the Elasticsearch database actually. So now we talked about saying that, okay, in a high level, we talked about how the entire solution works out, but now we are going to talk about a little bit more detail, saying that what is the data paths, how the data paths, how the data flow happens from the end to end. We will be talking about in this slide actually. So as I told you that a user goes to Axon and he will be providing specific information saying that I wanted to run on this particular server this many virtual users on this particular web application. I wanted to generate a load. So these all the information user will provide it to the Axon and as a web front end. And what Axon will do is that it uploads all this data, all the Docker information, all the Axon information, all the JMeter information to the database. So, and it creates a job in the Docker cluster. In the Docker cluster, it's called Docker service actually. DS means Docker service. In the Docker cluster, Docker Swarm means a Docker service means it creates number of containers technically in the backend. So if you say that I wanted to create like I wanted to create two users, basically what it do, it creates two containers on the two different load generators. Load generators are basically like a systems which has a Docker, which creates the containers like a VMs who loaded and load the JMeter application on the top particular container and generate the load actually. Okay, so looking that, if you look at it, a Docker service comes up saying that I wanted to run two users. There is a two containers came up, and each container has a unique ID which goes back and talks to the database and gets all the details like what is the JMeter script I need to run, what is the JMeter script which is to run, what is system details, and all the stuff it will get it. Once the Docker container get all the stuff using the JMeter application which is inside the Docker container, will launch with the script actually. So once the script is launched, using the script, it's the JAAS server with a particular application load, and it keep on hitting the system with the load what we are looking. Once we started seeing the load, at the same time, all the container related artifacts like a JMeter logs or a container utilization, all the information we store back into the Elasticsearch so that once the job is over, container will be removed and still we will be able to access the historical data which is in the database. As well as, we also send all the data on the server, the application logs, application utilization, application metrics also to the database so that we know that when we generate so much of traffic from a load generator on the server, what is happening, what was the utilization, what is the errors we are getting, all the data also we store it into Elasticsearch actually. So now we know that we started in a workload with the two users and we are able to keep pumping the data into the database, and we are seeing the data into the we are getting the data into the database. We are seeing the application stress on a server, and we're getting all the application logs also into database. Everything is good. Now the user wanted to increase the load or decrease the load. He can able to do it dynamically. So he comes again to the Axon. He says that no, I want to plan 2 users. Can you increase to 3 users? So when he says the 3 users, again the new container will come up, and the container will go back and read the data from the database, and it gets the database, it gets the JMeter script. Again, it starts the stress on the server and bumps the data back to the database. This is the life cycle of the particular workload. It keeps running and stressing the system, and also collects the artifacts into the database so that whenever user completes the workload, once the job is over, he removes all the containers. We will be still having the data in the database for the historical data mining. Okay, this is the pretty much high level data flow diagram for end-to-end whatever the workload we ran. All the artifacts, all the data will be stored in the database, and we will be able to stress the system seamlessly using the distributed workloads. So in the simplest manner, now we talked about saying that okay, the data flow from the end to end, but now we wanted to run across sites, across geo sites actually. Okay, so still people can, as I mentioned, seamlessly, people come to the Axon, they will say that what job they wanted. So these managers will be there who are actually assign the jobs into different locations. So what we have done is that we have geo-located the nodes or load generators with the different locations. For example, you can talk about Bangalore Development Center, there is a couple of nodes, and the Austin Development Center, a couple of nodes. We tagged it so that when a user says that I wanted to use a particular lab location as a load generator location, so automatically the job will be placed and it will be tagged to the particular nodes, and the containers will comes up in that particular lab, and that containers test the system. So we really don't encourage people to run from the Bangalore to Austin systems or Austin to Bangalore systems, because you maybe create a lot of bottleneck in the between the geo sites lab network pipe. So we actually encourage people to use the same location where they have the systems and the load generators to get the better workloads actually. Okay, so this way we are able to have a single solution scalable across the labs, across regions, without deploying any other instance, and able to manage the entire solution and get benefited actually. So some of the teams who are just, they may not need to know anything about solution, but they can able to leverage the solution using the distributed geolocated workloads across the sites actually. Okay, so now we talked about the data flow, and we talked about the solution. We talked about all the geo sites, how we can able to use. So currently, what we are supported. If you look at it, any programming language, you can able to develop any workload using the JMeter scripts in Java. Okay, so we developed a couple of workloads already. For example, we can able to hit that some of the web applications what we have. We are able to generate the load, or we have a file transfer workloads where it can generate high network traffic, or we are able to use if you have a mail server or a database server. Using this particular workloads, we continuously stress the system using the mail, keep running the mails, reading the mails, deleting the mails, attaching, keep sending high attachments to the mails and all the stuff, so that intermittently it creates a huge traffic on your mail application as well as the server actually. So there are a lot of databases are there. We supporting majorly what industry supported. For example, you can look at it an SQL server and a MySQL server and Oracle and MongoDB. Any database you look at it, we support almost all the workloads. We are also working on the next generation workloads also, which is basically like an OmniSky and other. These are the not a traditional workloads or not a relationship databases, which also be supported and integrated into this particular solution. Eventually, what I was trying to tell you is that it's a JMeter scripts which eventually create the load on the application. So we can able to write our own scripts and able to integrate into the Docker container and run across multiple systems as a containers, so that we can able to generate a huge amount of virtual users which can hit the systems and which can generate the load for us. So just a high-level statistics. It is nothing. I mean that for external people, this may not be big useful information. But what I'm trying to bring it up is that what is the cost we are able to save, how much projects we can able to run, what is the scale we can able to use the solution in our in any organization actually. Okay, for example, we have around like an 85 load generators across the globe, and we can able to run 2,000 plus containers. We can bring it up at the same time. We leverage this particular solution across 90 plus projects. 130 plus users have used this solution, and we ran over the last 2 years 20,000 plus workloads actually. Okay, which eventually generated like 3 to 5 million virtual users which test the systems and test the applications. So we started as a small solution initially with that simple JMeter, simple what you call it, JMeter scripts to test a particular application, but now we moved to a scale where the using completely an open source solutions and new technologies, and we built our own solution which can able to run a wide number of workloads across sites, across protocols on a different systems and servers actually. Okay, so what else we are working on? We are also having new workloads we are working on. For example, a customer can buy a system for a video streaming server or a ML workload or a social media server we wanted to use. So we also wanted to simulate that particular workloads in our lab. So we were actually working on these POCs to create these workloads in our lab, so that we can able to test same workloads in our lab before it goes to the market and goes to the customers. So these are a couple of new POCs which we are working on, and these are the next generation workloads which we wanted to take it up and use JMeter and use JAAS. We want to deliver it. Okay, so before that, I just have a small recording of the video of this solution. Okay, I will go to the little bit very high level so that you can get to know what exactly happens. So for example, we have a web server running on a particular system. Okay, and we want to test the system using that particular web server continuously and get a CPU utilization. You wanted to get utilized CPU for the particular system using this particular web application. Okay. Just an example of the workload we are going to demonstrate here. So for example, there is a system which is running on this particular web application. Okay, so it has a 2% utilization is running on the CPU. Okay, so we have a web application on the particular system. We actually this is the web application which generates random numbers on the system so that it can able to utilize the CPU pretty much. Okay, this is pretty sample web application we designed. Okay, so now we go to some of our web interface where we can able to search for a particular workload what we want to run, and then we provide all the information like what is the project we want to run, what is the web application we want to test, how many users we want to test, how many threads we want to run, what is the location where we want to run this particular workload. There's a couple of user inputs where we will be providing so that people can able to give this information so that the workload will be placed on a particular geolocated workload generators actually. Okay. Once this runs, what it basically do is that as I mentioned, this portal is a cluster software. It's again open source, so that it will show you that what services are there in the backend, how many containers are created in the backend. You can be able to monitor actually. So now we asked that one container we wanted to use it, and this is the backend. We can able to see the service and the one job. So now once the container comes up, it has a JMeter, it knows that what script it has to run. It continuously using that particular web application, and using JMeter it will start hitting the server, that 2 users. So if you look at here, that with the 2 users itself, we are getting almost like 60 to 70% utilization on a particular on a server actually. So this way we are able to generate the virtual load on a system using the particular web application actually. And then we started seeing that we have multiple interfaces to monitor what is happening on the server. For example, number of active transactions, what is the past percent of the transactions which is generated by JMeter. All the things we are able to get the data from the Elasticsearch and visualizing in the Grafana, so that user can able to monitor this data live on the Grafana itself. So once we started seeing that okay, the workload is running, we are able to see the data inside the Grafana. The next step is that we want to increase the load. For example, now we ran only 1 user. So now what we wanted to do is that we want to scale the number of users from the 1 to 2 users, so that we can able to increase the virtual users as well as the load on a physical system actually. So now what we provide is we provide 2 users. Automatically the service will be updated with 2 users, and there is a 2 containers will comes up in the backend. And once the 2 containers comes up, you can see the system's load here, which is actually increased from the 70% to almost like a 99% actually. So we wanted to hit the maximum utilization of the system with a web application with the virtual users. We achieved with this particular number of containers actually. So at the same time, we can come back to this particular screen and monitor that number of users, number of transactions, and error percentage, and all this stuff. So this way, what happens, the user has an option where he can able to scale up or scale down the virtual users based on his requirement dynamically. Okay, so that he don't need to really stop and restart again compared to like another workload or other tools. Here we can able to dynamically scale up and scale down actually the number of users. Now as a last step, we have an option where we can able to stop the workload also. So means that you can stop that workload so that the containers will be removed and the jobs will be stopped. And we can also see the system utilization goes from the 100% to 0, 2% to 1%. So this way the end user may not know what we are doing in the backend. We are actually orchestrating the container, we are orchestrating the JMeter script, and we are actually triggering the JMeter script, and we are collecting all the data from the system, collecting all the data from the JMeter container. We are visualizing all this data in the single console. So this way we actually completely encapsulated entire solution into the one big clusters orchestrated solution, and made people's life a little bit more easy to run the workloads, so that they don't need to really worry about JMeter scripts and all that stuff. And it is running across Geo Locations, so that some of the users who don't even know the solution of what it to do in the backend, they can able to run seamlessly actually. Okay, and this can be used. Solution can be run for any workloads. It could be a database application what we are building, or a web application what we are building, or in a storage application what we are building. We can use the solution, and all the software which I talked about here is all are open source ones, and you can able to see in the market in the Google or in the internet all the software, and you can able to use the solution for your purpose. That's pretty much from my side actually, and that's any question and answers I can take it up, and also please feel to share your feedback on the conference forum actually.
Okay, Vishnu, thank you. So we have 4 questions. I'll just bring them up on the screen. Hold on. So can you see the questions?
Actually, should I need to stop sharing these things?
Yeah, if you stop sharing and then. If you can't see them, I'll just read them out to you.
Yeah, I can see the screen actually.
Okay, so the first question from Peppa. Are you running your performance tests during functional and system testing or after that, before the release?
I think that's the system testing is the right word there. System testing phase, we run this particular performance tests. Okay. Mainly to make sure that how the system is performing, but in the functional testing time, that independent individual component teams, they do their own functional testing and they do performance test. In the system testing time frame, we do the performance testing more on applications what customers uses on the servers what we sell, so that we will look at it how the way it's behaving, it's performing actually. But it's before release actually. Okay, before release, after functional testing, we do the system testing where we do this particular performance and load testing.
Okay, but you have got the teams, the development teams are actually using this tool themselves to do performance testing early in the development lifecycle.
Absolutely.
Which is these days the good practice. Okay.
Absolutely. So I think one of the advantage also, if you look at it, when we used to use it traditional, the tools which we used to use, market tools, in the tools which are in the market, one of the major challenges are when we see any issues in system testing, if the development team wanted to reproduce the same issue, it's very difficult because they may not be in the same network, they may not be very close to the solution and all the stuff. But because of JAAS, which is geo-located across locations where they can able to use, developers also can able to use the same solution and able to reproduce the defects in their own lab itself. They don't need to know anything about the solution, what to set up and all this stuff. They can able to connect the system to the network and they can able to get test using this particular solution. Okay. Yeah.
So the next question from Marcel, what is the typical system under test? And why do you need the geolocation distribution?
Absolutely. So the typical SUT is like a server with an application contains, for example, a database server, okay, with a different memory specifications, with a different CPU specifications. That's what the server and test we call it out. Okay, a server with an operating system with an application is packaged as server and system under test and server and test. Okay, and why you need a geolocation distribution? Because there are teams who are in Bangalore and Austin. So if we have actually a centralized entire setup, so the challenge is what happens is that when we have heavy traffic over the network pipe, which is different locations using, then we will not get the best network traffic actually. Instead of that, we distributed the workloads across locations so that the teams who are in the particular location can run the workload on the servers which are very close to their load generators, so that you don't generate too much traffic outside of the particular location actually.
Yeah, okay.
Okay.
And the next question from Carol, can it support complex parallel workload simulations? For example, back-end and front-end load in parallel. I think it's...
Absolutely, yes, actually. Okay, because it's all with a simple JMeter script. You write like a simple Python script or a shell script or Python, anything you can write it, which can able to do your backend or front-end applications. And then your containers and your JMeter will help you to run parallelly with multiple threads, multiple virtual users across the load generators. So your workload, it could be complex or small, it takes care seamlessly and running parallelly across load generators actually.
Okay, and can you synchronize those activities? For example, you can say that, okay, there's a batch that's going to run from 10 p.m. till 12 p.m. I want to see how the front end is working while the batch is running. You can synchronize those things.
Absolutely, yes, we can. That's where we are actually using this particular dynamic profile workload, where we can actually specify the time range. So for example, I want to run in the morning time frame. In the customer world also, in the morning time frame, you will see that there is too much of load is generated. In the night, it will be goes down. For example, there may not go. So we can actually profile the same way, where the number of containers in the morning could be like in a 5 to 8, and the evening could be 2 to 1. So once the containers goes down, automatically the load will be reduced and it will goes out. Again, in the morning, the number of containers will be increased to 2 to 8, and you will start seeing the more number of users actually. So we can able to sequence, we can able to schedule, and we can able to plan such a way that we can become more like a real-time customer workloads.
Okay. I think hopefully we'll have time for me to ask my own question at the end. Okay, so the next question from Andre. How do you empower the rest of your organization to add more tests inside the described system?
Absolutely. So initially we looked at it at traditional application workloads, but now we started seeing more and more requirements from the different users to run a different workloads actually. So now we are actually getting more popular as this solution, and also it's completely open source. You just need to get the script and put it in a container. Everything takes care the Docker system and the scripts actually. So we are actually educating more, and we have started showing the cost savings of the solution because there are no licenses, there are no proprietary hardware. You can able to bring up your own old hardware also into the system, and we can able to get replaced and get benefit from the solution. And we are not paying any money for the softwares or anything. We just build the infrastructure, we build the software stack, and it runs its own way. We don't need to really worry about it. Yeah.
Okay. Do you envisage that it'll get so popular that there'll be sort of too much demand for the solution?
Yes. We started seeing that the trend, what we are using 1 year back, and now the number of projects are increased, number of workloads are increasing because at different sites people are using the solution.
Yeah. Okay, so you'll need a scheduling solution on top maybe eventually. Okay. And the final question we have here is from Pepper. So far, there's still time to ask questions if anybody wants to ask anything. Why are you using Grafana with Elastic and not Kibana?
Absolutely good question, because Kibana actually doesn't have this particular security or IAM, identity access management system. So because it's a licensing feature in Elastic Stack also, that particular feature. So what we try to do is that we use the Kibana for the backend infrastructure monitoring and Grafana for the end users, where we implemented the access management actually, so that we know that who are accessing our dashboards, our visualizations, our charts, so that Grafana supports that access management. So we use the Grafana backend as Elasticsearch, then Kibana with backend as Elasticsearch, mainly for the access management purpose.
That makes sense. Okay, so I have a question. How long did it take to build this solution? How long did
I think initially we learned a lot of technologies. We started exploring the things. It took like 2 to 6 months, or 2 developers continuously working on the thing. But the major part is that learning curve. Okay, understanding different solutions, their purposes, their application, API stack, and all the stuff. Okay, but now I see a lot of material is available in YouTube or in a Google. You can able to read out a lot of material and you can bring it up more easily actually. Previously, like 2 years back, it was very tough to find how all the applications, their endpoints, their APIs, how they behave and all things. We did a lot of research and we did a lot of testing. But now I see there are a lot of materials available. I think this is one of the main purpose for me to come out and talk about these things in conferences, so people can know these technologies and they can able to leverage actually. Okay, it's just seamlessly. There's a lot of open source solutions that are there. We can just make a simple solution, integrate with all this open source solution, and we can make it pleasant.
Okay, thank you. So that's all the questions. So thank you very much. It was very, very interesting and quite inspiring. Oh, I have one extra question. You mentioned at the beginning traditional tools like LoadRunner.
Yes.
And this tool. What do you see do you still see some pros for using something like LoadRunner against building some sort of open source tool?
Yes. See, if you look at it, LoadRunner and proprietary tools with the tools which we build, okay, the tools which we build will have customization. The LoadRunner is basically comes with an enterprise class, correct? You have a tech support, you have a continuous support, you have continuous plugins, continuous support from the LoadRunner and all the stuff. Okay, because there is always an enterprise software and in-house software is in-house software actually. Okay, so you will still see there is an advantage in a LoadRunner or in Ixia and all these solutions. But there is certain requirements you wanted to drive in your organization, like in metrics, analytics, or reducing the cost of your entire testing, or building their own, reusing your own hardware. So there is an advantage both sides. But yeah, they are the industry leading load generator tools actually. They are the best ones in the market.
So with your own tools, you have flexibility. Yep. With the enterprise, you get the support and the existing know-how, I guess, at a price, of course.
Yeah. And also you need to know that basically you need to have time to build the solution. You need to look at all the things. You want ready-made solution, you can go back. And in fact, if you want a ready-made solution, you can able to simply use JMeter also. Okay, you can just go to JMeter and find out a JMeter scripts which are internet. You can able to evaluate. You can find out, just run it, and you can able to get benefit. But you want to have a massive scale. Okay, because your systems are so many systems, you will have so many applications you want to test. Then you need to build a proper solution which encapsulate everything from end user, and so that end user will have seamless experience.
Okay, so Vishnu, thank you very much. If I